Yes, ma'am, you're audible.
All right. So, Ranim, in the last class, we have completed the EMI chapter. Let's start with AC then today.
Ma'am, before that, I had a few doubts in this magnetism and matter chapter.
Okay. Tell me.
Ma'am, there is one derivation that proves that current carrying solenoid is an equivalent to a bar magnet.
Current carrying solenoid is equal to a bar magnet.
Yes,
B is
ma'am,
equal
that
to Q naught
derivation we
Ni.
have to prove.
Yes. Okay. Okay. I get it. I get that derivation. All right. That one. Anything else? That question actually is a
Ma'am,
question from your boards. Yes.
oh, ma'am, uh, the mu r is equals to 1 plus chi. That
That
they
we
show
have
that.
done.
Yes, ma'am, but I didn't quite really get when
Okay.
I tried to study on my own.
All right. All right.
And ma'am, Curie's law.
Curie's law. Ranim, did I share any table with you?
No, ma'am.
I'll just share it. Okay, Ranim, that table I think I haven't shared with you. Yes, I'll share there the Curie's law and all the paramagnetic, diamagnetic differences are all written. Okay, Ranim. So these three things.
Yes, ma'am.
Anything else?
Anything, ma'am? In the notes given, it's properties of diamagnets, paramagnets, and ferromagnets. It's
Uh-huh.
given in a much more expanded form than explained.
Notes. Which notes?
Ma'am, printed, I mean, like the one our school gave, this is actually self-study chapter. So, ma'am, in school they didn't teach this.
Oh, chapter 5 they didn't teach. Oh, she was telling, you told that your teacher was telling that she'll do it at the end. So now they just said to do it on your own.
Yes,
See,
ma'am.
Raneem, the calculation part is not definitely a self-study part, but the portion where you have the substances, that's definitely a self-study thing. That I also cannot help you. Two things are there in 12th where I can just have a discussion. Same, the way your teacher said. One is the magnetism, those three substances, dia, para, ferro, and one is in the EM waves chapter, the electromagnetic spectrum. So let me do one thing, Dani. Let me start with this chapter a little. At least let us start with AC. Otherwise, see, doubts can be taken any time. Okay, let me start with a bit of alternating current. Just understand alternating current. Do one or two derivations. Let me share that table with you first. So I think majority of the portion will be clear to you after that table is shared. In that table, where everything is given in a very precise manner. Okay. So let me share that. You have a look on that. Then definitely I'll discuss all these. Or at the end of the today's class only I'll discuss at least one or two derivations I can. Then the for chapter fifth part we'll discuss in the next one. But chapter fourth doubt we can take today. Okay. This way the chapter will also go and your doubts will also go simultaneously. All right.
Yes, ma'am. Okay, ma'am.
At the end, I'll discuss that derivation of that proof that bar magnet wave the solenoid waves the bar magnet. That one we'll discuss. And let me share that table so that fifth chapter I can take on Wednesday. Once you go through that table, then whatever doubts you have, I'll discuss it. Okay. See, direct current meaning of what is the meaning of direct current and alternating current. Direct current means current is there with its some value, maximum or minimum any value. Let's say current is equal to 2 ampere, or current is equal to 4 ampere, or current is equal to 8 ampere. So, like this, the values were given before this. Before this chapter, every time you had a fixed value of current. Current was equal to 2 ampere, current was equal to 4 ampere, current was equal to 8 amperes. So current's value was fixed, right? Now, when we talk about the direct current means its value will not change with respect to time. So zero is there and after some time it will at 1 second it will have a certain value of current. After 2 seconds it will have a value of current. 3 seconds it will have a value like this. With increase in time, the current's value will remain fixed. You never have any current like I is equal to 3t square minus 5 and all like this. You never had any current. So that is a direct current. It doesn't change with respect to time. Whenever whichever questions we did, if a single wire is there, that single wire will have a certain fixed amount of current or not. Yes?
Yes, ma'am.
So that is your direct current. Alternating with the term only you can understand. Alternating means fluctuating. So current varies, okay? The current changes. So that is what is meant by alternating current. So current varies sinusoidally. Okay, sinusoidally basically or cosine curves, both curves you can obtain. Means sinusoidally or cosine means cos theta curves, sine theta curves. For every angle, you have graphs also. In maths, we do this in detail. So if something is varying sinusoidally, so you obtain a sine curve. If something, when you have a cosine curve, so cos graph starts like this, cross graph looks like this. So these graphs means these graphs show that at different times, at different point of times, you have different values. Let's say here this is 1, here 2 seconds, 3 seconds. At every second you can see the amplitude is different. So fluctuating current is known as the alternating current, which is used by the common term AC. Okay, and we have a very important application of AC generator dynamo, which is based on your EMI chapter. That's why I have included this at the first. Okay, so do one thing, just write down the introductory part. Then let me discuss AC generator with you. Okay.
Okay. I'm done. I'm done.
See, when we talk about the AC generator, it is it is just similar
Ma'am,
to.
you're not audible.
I'm not audible.
Ma'am, I can't hear you.
Raneem, I'm not audible. Am I audible?
Ma'am, I can't hear you.
Raneem, am I audible now? Is it audible?
Ma'am, I can't hear you either. No.
Is it audible, Raneem, now? No. Um, Ranim, is it audible now? Yes, Ranim, is it audible to you now? Are you able to hear? Yes, Ranim, are you able to hear now? Is it audible to you? Ranim, check. Are you able to hear?
Now you're audible.
Now I'm audible? Okay.
Yes, ma'am.
Because somebody from the team also got connected, so they were able to hear. That's why I asked you to rejoin. Okay. Now it's clearly audible to you?
Yes, ma'am. You're audible.
Okay. All right. I was saying that we are going to discuss AC generator. Now, AC generator is basically known as AC dynamo, also that works on the principle of Faraday's law. So, Faraday's law we have already studied in the previous chapter, EMI. So, the same Faraday's law will be applied here as well. Now, AC generator or dynamo does what? It does the function of converting whatever is the mechanical energy. Now, what is mechanical energy? Mechanical energy is basically the energy, combined energy, kinetic and potential. Means kinetic energy plus the potential energy is the mechanical energy.
Ma'am, the physical
Physical
movement.
energy,
Right?
yes, exactly. Due to movement that comes. Mechanics of your class 11th entire mechanics.
Yes,
So that
ma'am.
mechanical, that movement, it takes that and it converts it into the electrical energy. Now, which kind of electricity? The electricity is your alternating current, electrical energy. Okay. The principle is that it is based on Faraday's law. Faraday's law, exact same Faraday's law that we have studied earlier as well. that whenever flux changes, EMF gets induced in the coil. Okay, flux, magnetic field changes, flux changes, EMF gets induced in the coil, same thing. This is what is the meaning of the Faraday's law. So same E is equal to minus d phi over dt. This same principle will be applied here as well. Okay. Now, in AC generator, AC dynamo, basically you have the entire magnetic flux getting changed because of the rotation of the coil. That is why we say mechanical energy gets converted into the electrical energy. So why does and how this happens is you will be able to relate through its structure first. First understand its structure, then we'll come to the formula part and the rest of the things. See, basically you have permanent magnets taken, permanent magnets are there, and magnetic field run from north to south. And there is a coil is present, which is put on some slips. These are the slips, so that this can rotate. And the slips are held on an armature, basically a
Ma'am,
stand where you
what
can
are, ma'am, is that coil square?
rectangle, rectangle. Usually the coil
What
taken
are,
for AC generator is rectangle.
ma'am, what are slips?
What slips? Just two slips so that it can rotate, allows the rotation of the coil. Otherwise, it will be rigid. So how will it rotate? There should be some slip pre-movement allowance, which is
Yes,
put
ma'am.
on armature. Armature is just like a stand on which two slips are put. Now the coil can rotate. Right? So see, basically what happened here is the coil rotates with some angular velocity omega. This is the angular velocity. So omega. Okay, this coil rotates. Now we have studied the basics of flux, that is BA cos theta. We
Yes.
have studied that. So surface
Yes,
area of the coil. I'm just telling you in a gist. We'll do this in detail, but just a bit idea so that you can figure what all things are coming ahead. The coil will have its n cap. Area vector will be there, and the magnetic field is already present. Correct. Magnetic field is also there, and the area vector will also be there. So both of them will forming an angle, which we consider in the flux, BA cos theta, that
yes,
angle.
ma'am.
So see, when the coil rotates, magnetic field will be fixed, but the area vector will be changing. Different directions will be coming for the area vector.
N
Will it be
cap,
not?
ma'am.
N cap, yes. N cap will change if the coil rotates. If my coil is like this, if the coil rotates, so what will happen? Area vector will change. Sorry, not
Yes.
area vector. Theta angle will change because area vector is getting moved. So that's why we get alternating voltage here, because voltage is depending on angle, which is continuously changing. And since voltage is fluctuating, you get alternating current in the system. This is all in a small crux to understand, though we'll discuss everything in detail, how and what are the equations. But a basic gist you must have understood. Why do we have AC in AC generator? What is
Yes, ma'am.
alternating exactly? This is alternating. Simple logic is there, which we have already studied. When is number of turns, A is the area of coil, B is the magnetic field, omega is the angular velocity. Now we'll connect all these things, but do one thing. I did till here. Then let me discuss the AC coil first. AC generator, I'll complete first.
Yes, ma'am. I'm done, ma'am. I'm done. Ma'am, done, ma'am.
Okay, Ranim, the variables you can write later. See, flux that we have, flux is equal to B
Ma'am,
dot A.
you're not audible again.
Rejoin.
Yes, ma'am, I'll rejoin.
Yes, Ranim, am I audible to you?
Yes, ma'am.
Okay. So phi is equal to B dot A, correct? That's what we
Yes,
write.
ma'am. Yes,
So
ma'am.
flux can be written as B A cos theta. Now here one modification I'll do, that is instead of writing theta, I'll use angular velocity because the coil is rotating. So angular velocity will be used. So I'll also put angular velocity. Now, do you remember any relation from class 11th, Raneem, which connects angular velocity and angular displacement? Hmm? Angular velocity, angular displacement.
Ma'am, sine omega t, like that.
No, no. Linear velocity is equal to linear displacement by time. Angular velocity is equal to angular displacement by time. Yes.
Yes, ma'am.
So I can write phi is equal to PA cos from here. Theta can be written as omega t. So this will be BA cos omega t. Okay. Now EMF we know is minus d phi over dt according to Faraday's law.
Yes, ma'am.
This is Faraday's law. So when I put the values here, E is equal to minus. Now this is BA cos omega t. So basically I am differentiating this whole term BA cos omega t. Now see B and A will come out cos omega t. When you differentiate cos omega t, you get minus sine omega t. Yes. Cos theta becomes on differentiation minus sine theta. Okay.
Yes, ma'am.
Now see, one more concept here that I think we haven't discussed now. This is the first time this is coming. Huh. Yes. See, remember, Ani, whenever you differentiate a quantity, and a constant is there in the angle, that constant term comes out and gets multiplied. Like here, omega is a constant. Angular velocity of the coil is fixed. So you will get this omega will be multiplied. So you have to write minus omega sine omega t. So this way this will become, this is B A omega sine omega t. Now is this much clear?
Ma'am, why omega t again?
Not omega t. T is a variable. Time will fluctuate. Constant counts. Whenever you have no sine k theta, anything. So when you differentiate it, whatever is it, cos or whatever you're writing, let's say cos, this comes out k and gets multiplied. This constant gets multiplied. So if you
Yes,
or
ma'am.
if you are differentiating cos theta, cos k theta, this is a rule of differentiation. So instead of understanding its derivation, just remember it because this much only will be utilized here. Whatever a little bit of identities will be used from your maths, that I'll tell you here itself. And I'll suggest you don't have maths, Rani,
No, ma'am. I took bio.
and you have bio, yes, and you don't have to appear for JE then. You just are preparing for NEET only. So
Yes, ma'am.
Just remember those identities, those are sufficient. Just learn them, mug up them. Because you don't have maths, you don't need it. It's sufficient for bio. Okay? And NEET also, the papers, they do not ask the identities out of the box. This will be K sine theta, whatever is it, with a negative sign. That's why omega sine omega t. Remember that your cos omega t will become minus omega sine omega t. Remember it like this.
ma'am.
Okay, now this is just for one turn. For n number of turns, we'll write nba omega sine omega t. This is the equation of EMF for the coil. All right, the rotating coil will produce this EMF. This is its derivation. Now, there's one more point that is used a lot. We get maximum value of EMF. For maximum value of EMF, sine theta, the sine omega t, the sine theta, this should be equal to 1. That's the maximum value of sine. You don't have 2, 3, 4 for trigonometric values. Maximum
Yes,
is
ma'am.
1. So omega t should be equal to, when is
One.
sine theta 1? When is sine theta 1? This is theta, no? This part,
Ma'am, 90.
90. Omega t is 90, you get E max. That is, E max will be NBA omega. This is used often. Okay, so NB omega means the maximum value. Your sine part is 1. We put no sine 90 degree and then we write 1, so it's just written already. So graph will also be variable, and this is the positive part of the graph. Negative, it will continuously change depending on the angles and everything. It will change. And this maximum value will be plus NBA omega. This will be minus NBA omega. This derivation is clear, Aneem?
Yes, ma'am. Ma'am, but the construction part, like the visual, I'm not getting
So
how
that
it
I'll
is.
tell you. I'll tell you. This I'll show you with the help of picture. Because without the diagram, it won't be clear. Or let me just give you an idea right now. So that a little bit idea is there. So while you're writing, then I'll show you the picture. That picture you can draw. See, let's say this is the coil. Rectangular coil is there. Okay.
Yes, ma'am.
And let's say the magnetic field is in this direction, pointing towards the right side. So keep in mind, magnets are not changing. Magnetic field line is fixed. Now, where the area vector will go? Towards you, into the screen,
Yes,
like this.
ma'am. Normal.
Right now,
Yes.
the angle is 90 degrees. Now the coil turns, but magnetic field won't turn. Magnetic field will still be like this. But the
Yes, ma'am.
area vector is like this. Now angle has changed. Like this, what happens is the coil is there, coil rotates all different angles. The angles that you have to remember will be 90 degree, 180 degree and all. So like this, like this, like this, it will change, it will change, it will change. Like this will change. And this is how the rotation of the coil affects this EMF. I'll show you a picture also that you have to draw. I think it's on some other page, but I'll just put it here. You can draw it in one go because that is important that you have to draw. Yes, there. Anyways, I'll add it here. It's not there. That after this, no, just draw that below only because it's there in the NCRT as well, and it's the part how the different angles are put. Look, Ranim. See, can you understand a bit now?
Ma'am, it's not like I don't understand what this CN or like.
I'll tell you. See, this is the north pole of the magnet. This is the
Yes,
south of the magnet. Okay. Coil is put in a manner like this. Okay. Coil is put like this first. This is how the coil is put. Look, this A,
yes, ma'am.
B, C, D, like this. This is the coil. Not exactly B. B is just for magnetic field. A, H, C, D. H is there. And A is whatever it is. This is the coil. Okay, magnetic field is present. Now see, coil rotates like this. This is how the coil rotates. So what happens? 1/4 of the complete rotation is covered. If I go 90-degree, remember we did a question in EMI. We divided into 4 parts.
Yes, ma'am.
So similarly, 1/4 of the time is covered. That's why this is written 4, 2, 3 t is equal to 4, complete t time. You understand it like this. Complete time to cover the rotation is capital T. So the way we did this will be t by each will be t by 4. This then here it will be t by 2. Then this point will be 3t by 4 and this will be complete t. This we have already discussed. Remember t by 4, t by 2, 3t by 4, t.
Yes, ma'am.
So basically, this is getting changed by 90-degree. Every point it gets changed. Look at this surface. Like this, like this, like this, then like this. Okay, like this. Till the time it comes back to its initial position. Look, it has gone like this. Then it further tilts to 90-degree. Then again by 90-degree here. Then again by 90-degree. So the back surface is on the front. Front is on the back. Okay, again by 90-degree. So starting position is retrieved. So this way the curve, this is the curve that I was referring to, which we get as the alternating current. Reason is this. Now it's clear? Oh, it's written also T by 4, T by 2, 3. Oh, I didn't see this. Look here. T by 4, T by 2, 3T by 4, capital T. Now got it, Raneem?
Yes, ma'am. So, ma'am, this curve represents the extent to which current is varying.
Yes, EMF. EMF. Right now we are focusing on EMF. Okay. Because when you divide the EMF with the resistance, current will automatically be there. Clear, Raneem?
Mm.
Ranim, just do one thing. You write down these portions and just text it done in the chat box. I'll have to pray Maghrib right now only because now the time has shifted. No. So when your class will end, the time will not be there. Okay. So you
Okay.
just write
Ma'am, last part I was writing. Ma'am, done. Ma'am, done.
Running over? Ranim, are you done?